Inside one of the most advanced scientific facilities on Earth, a decision was made that may define humanity's understanding of the universe for generations to come. No alarms sounded, no emergency press conferences interrupted global broadcasts, and no coordinated public announcements came from NASA, ESA, or any major international observatory tracking the most mysterious object ever recorded entering our solar system. Instead, something far more unsettling took place: complete, unbroken silence. Researchers at the Jet Propulsion Laboratory in Pasadena finalized an institutional response regarding the object known as 3I Atlas, right after it completed a precision passage through Jupiter's gravitational sphere of influence. The object was already leaving the inner solar system, accelerating back toward the darkness beyond Neptune, but independent analysts studying the tracking data argue that this total absence of public reaction was not mere caution, but deliberate communication. Silence at this level is never random. When every major space agency simultaneously avoids public discussion about the exact same event, when no scientific briefings are organized despite unprecedented findings, and when peer-reviewed studies disappear from public visibility almost immediately after publication, investigators begin asking a dangerous question. What did they discover that they no longer feel comfortable discussing openly? The answer begins with data collected by the James Webb Space Telescope during the object's perihelion passage, the point where it traveled closest to the Sun. During this phase, intense solar heat exposed material hidden beneath the object's outer layers, allowing spectroscopic instruments to analyze its chemical and isotopic composition in extraordinary detail. What Webb discovered reportedly shocked researchers across multiple institutions because the object turned out to be ancient beyond human or planetary comprehension. According to isotopic readings circulating quietly through independent research channels, the nucleus of 3I Atlas appears to be between 10 and 12 billion years old. Modern cosmology estimates that the universe itself formed approximately 13.8 billion years ago, while our solar system is only 4.6 billion years old. Earth formed long after this object was already drifting through the cosmos. That means 3I Atlas was navigating interstellar space for billions of years before Earth condensed from cosmic dust, long before the first oceans formed, or the earliest living cells divided in our primordial waters. The chemical evidence supporting this incredible age appears unusually strong. Researchers analyzing the object's isotopic profile identified deuterium concentrations far exceeding anything ever recorded in ordinary cometary material, alongside carbon isotope ratios that existed completely outside the normal range associated with objects native to our solar system. These are not small deviations. Readings point toward formation conditions that no longer exist anywhere in our local galactic neighborhood. In other words, 3I Atlas may have originated in a region of the Milky Way formed during its earliest, most violent epochs, back when heavy elements were rare and the galaxy looked nothing like it does today. That realization alone should have triggered worldwide scientific debate, but while James Webb was reconstructing the object's chemical history, another mission was collecting something potentially even more important. The European Space Agency's JUICE spacecraft, officially known as the Jupiter Icy Moons Explorer, happened to be approaching Jupiter during the exact same period that 3I Atlas entered the Jovian system. Positioned in an incredible alignment, JUICE carried instrumentation vastly more advanced than anything available on Earth-based observatories. Its Janus optical camera captured high-resolution imagery of the object, surrounded by a massive cloud of dust and ejecta. ESA released a single black-and-white photograph publicly, and then the conversation abruptly stopped. The single black-and-white image was only the beginning, but it contained a detail that independent investigators refused to ignore. The GI's spacecraft carries far more than cameras. It is equipped with advanced spectrometers capable of identifying molecular composition, particle detectors designed to measure environmental density and velocity, and magnetometers sensitive enough to detect electromagnetic fluctuations across enormous distances. GII was not merely photographing the object, it was scanning it completely. According to analysts studying the silence surrounding those measurements, the real story exists inside the data that was never released to the public. ESA officially confirmed that the observation occurred and showed the visual photograph, but the electromagnetic readings, particle analysis, spectroscopic measurements, and energetic signatures remain entirely absent from public archives. This massive omission has become one of the most debated aspects of the entire event, because if the readings supported a harmless, natural explanation, there would be little reason to withhold them. The deeper independent researchers examine the institutional response, the more deliberate this silence appears, indicating an awareness of implications considered far too disruptive for conventional public channels. Meanwhile, 3I Atlas continues moving farther away from the Sun, fading into the darkness beyond Jupiter and becoming harder to observe with every passing hour. The visible dust cloud surrounding it is weakening, thermal activity is declining, and the object that dominated observatory discussions for months is gradually disappearing back into interstellar invisibility. Yet as 3I Atlas continues its exit, the debate surrounding its origin has shifted dramatically from chemistry to orbital mechanics. The isotopic evidence already suggested the object came from a region of space older than our solar system itself. But what truly unsettled orbital analysts was not just where the object came from, but how precisely it moved once it arrived. According to trajectory data examined through independent tracking models, the object's passage near Jupiter was not merely close, it was mathematically extraordinary. 3I Atlas approached Jupiter at a distance of approximately 53.6 million kilometers. At first glance, that number sounds enormous, but in cosmic terms, it represents an almost impossibly precise alignment, passing roughly 100,000 kilometers inside Jupiter's hill sphere, where the gas giant's gravity dominates over the Sun. Under ordinary probability models, the chances of an interstellar object threading so closely through Jupiter's gravitational boundary are extremely low. Yet 3I Atlas did exactly that. And it did not simply pass by Jupiter, it deliberately used Jupiter. Orbital mechanics specialists describe the event as a gravity assist maneuver, or a slingshot effect. Humanity has used these exact maneuvers for decades in deep space exploration, sending missions like Voyager, Cassini, and New Horizons near massive planets to steal a portion of their orbital momentum and accelerate without consuming fuel. These trajectories require extraordinary planning, where engineers calculate approach angles down to tiny fractions of a degree to ensure spacecraft gain speed while escaping gravitational capture. 3I Atlas executed the exact same type of maneuver, but here's where the situation becomes difficult to dismiss as ordinary celestial motion. The object performed this maneuver on its outbound trajectory after already entering the inner solar system. It did not accidentally fall toward Jupiter while drifting inward from deep space. Instead, it used Jupiter's gravity during departure, gaining enough additional velocity to leave the solar system at more than 60 kilometers per second, moving with intent. That intentional behavior has forced orbital analysts into deeply uncomfortable territory because the outbound trajectory appeared unusually clean throughout its entire transit across the inner solar system. Instruments detected small but persistent non-gravitational accelerations acting on the object that could not be fully explained by solar radiation pressure or random outgassing. Under normal conditions, a natural object experiencing unpredictable outgassing forces leaves behind a chaotic orbital signature filled with slight deviations, irregular path corrections, and small distortions accumulating over time. Instead, the exit vector of 3I Atlas remained remarkably precise. According to tracking telemetry, the object appeared to apply internal directional adjustments with exact timing before shutting them down at carefully calculated moments. Analysts comparing the data to human spacecraft maneuvers noted a troubling similarity, as the trajectory resembled controlled navigation architecture far more than passive cometary behavior. That conclusion alone would already be deeply controversial. But the real fracture inside institutional science began when researchers analyzed the material released from the object during its close solar passage. As 3I Atlas approached, perihelion, thermal heating, triggered massive outgassing events from beneath its outer layers. Spectroscopic instruments identified complex organic compounds emerging from the nucleus at accelerating rates, including carbon-based molecules and structured organics that require very specific environmental conditions to form and survive. The problem is not simply that organic compounds exist in space, since scientists have discovered organics in meteorites and molecular clouds before. The real problem is long-term preservation. Cosmic radiation floods interstellar space constantly, and over billions of years, unprotected organic material should break apart into simpler molecular structures. Yet the compounds released from 3I Atlas appeared unusually intact despite supposedly spending 10 billion years crossing the galaxy. This creates an engineering problem that no conventional cometary model easily solves. How do fragile organics survive uninterrupted exposure to harsh radiation for such incomprehensible periods of time? According to alternative interpretations spreading through independent analysis communities, only one explanation fits the available data. The organics were shielded, protected, and sealed beneath structural layers capable of preserving molecular integrity across cosmic timescales. That possibility changes everything, because once researchers begin considering deliberate shielding, the object stops resembling a random comet entirely. Instead, it begins to look like something structured, something layered intentionally, something designed to carry preserved material safely across vast interstellar distances. Even more unsettling is the precise way this material release occurred. The compounds did not emerge randomly, but appeared during very specific thermal thresholds as the object approached the sun, almost as if the heating event itself triggered a controlled exposure sequence. Investigators studying the pattern argue that the release mechanism behaved less like chaotic solar sublimation and more like a system responding to specific environmental activation conditions, active near the sun, inactive in deep space, visible briefly, and then hidden again. Meanwhile, during its Jupiter passage, 3I Atlas crossed one of the most scientifically important regions in our solar system, passing right through Jupiter's system near the ocean moon Europa, one of humanity's top candidates for extraterrestrial microbial life. According to trajectory calculations, 3I Atlas passed close enough to measure Jupiter's intense magnetic fields, radiation belts, and chemical signatures, meaning that if it carried any sensing capabilities, it collected vast amounts of data before leaving cleanly toward interstellar space. That exact sequence of events, observing, measuring, and departing, is precisely what has driven independent researchers toward their most unsettling theory yet. 3I Atlas may not have entered our solar system randomly at all, but entered with a clear, deliberate purpose. From a purely observational standpoint, its flight path achieved almost everything an exploratory probe would need to accomplish, including solar analysis during perihelion, gravitational acceleration from Jupiter, exposure to Europa's astrobiological environment, and a clean outbound escape vector toward interstellar space. Throughout all of this, the world's largest space agencies chose absolute silence. There was no emergency mission proposal, no intercept authorization, and no public discussion explaining why humanity allowed the most anomalous object ever recorded to leave our solar system without direct investigation. As 3I Atlas continues fading into darkness beyond Jupiter, the observation window is shrinking rapidly, and soon solar energy will no longer sustain visible outgassing, causing the object to disappear completely. By the time 3I Atlas completed its gravity-assisted departure, public attention had already started fading as news headlines moved on. To the average observer, the interstellar visitor looked like just another unusual space event passing briefly through scientific conversation before disappearing into history. But inside research circles following the deeper details, the situation was moving in the exact opposite direction. While the public saw silence, investigators saw missing information, and the most critical missing data appeared to be locked inside the archives of the JOICE spacecraft. When ESA released the single black and white image captured by UIC's Janus camera, it showed a bright central nucleus surrounded by a large dust envelope expanding through space as the object crossed the Jovian system. Visually, the photograph was impressive, but strange as it was, it still seemed explainable. The real issue was never the single image itself, but everything else JUS recorded during that encounter. Unlike ordinary space telescopes observing from millions of kilometers away, JUICE was positioned directly inside the Jovian environment with a full suite of specialized instruments designed for deep environmental analysis. The spacecraft carried spectrometers capable of identifying complex molecular structures, particle analyzers measuring material density and velocity, plasma detectors tracking charged particles, and highly sensitive magnetometers capable of detecting subtle electromagnetic fluctuations across enormous distances. In simple terms, JUICE did not merely photograph 3I Atlas, it scanned it completely. According to analysts reviewing the timeline of public disclosures, the most revealing data never reached public release channels. ESA openly confirmed the observation occurred and distributed the initial visual image, but the electromagnetic readings, energetic signatures, molecular analysis, and particle environment measurements remain absent from public archives. That gap has become one of the most heavily debated aspects of the entire event because the omission appears highly selective. Visual confirmation was allowed, but structural and environmental analysis was strictly withheld. Independent researchers studying this silence argue that if the readings supported a fully ordinary natural explanation, releasing them would strengthen institutional credibility rather than weaken it. Instead, the data entered a restricted review process immediately after collection, a timeline that aligns perfectly with the sudden spread of institutional silence across NASA, ESA, JAXA, and global observatory networks, leaving major scientific panels entirely silent, while anomalous electromagnetic readings leaked quietly through independent channels. Among the leaked details, one of the most heavily discussed involves the object's magnetic environment. Ordinary comets and icy bodies interact with solar wind in predictable ways, displaying weak, chaotic magnetic signatures that are heavily shaped by external solar forces. But analysts examining fragments of leaked telemetry summaries claim that the magnetic fluctuations surrounding 3I Atlas displayed structured periodicity instead of random turbulence. That distinction matters enormously because a structured electromagnetic environment implies internal organization. It does not necessarily prove active machinery, but it points to some form of coherent internal architecture capable of producing stable energetic behavior under conditions where random natural systems fluctuate unpredictably. At the same time, particle detectors aboard JUICE reportedly measured unusual distributions within the dust envelope surrounding the object. Instead of simple ice and rock fragments dispersing uniformly through space, readings suggested layered particle populations with sharply different density characteristics. Researchers comparing the data to known cometary patterns noted that portions of the material behaved more like controlled release structures than chaotic sublimation clouds. None of this individually proves intentional design, but the accumulation of anomalies continues growing harder to dismiss. An ancient isotopic composition, precision gravitational maneuvering, a controlled outbound trajectory, preserved organic compounds surviving billions of years, structured electromagnetic behavior, and a layered ejecta architecture. Each observation increases pressure surrounding the central question institutional science appears increasingly unwilling to answer publicly. What exactly is 3I Atlas? The object no longer fits comfortably into conventional categories, behaving partly like a comet, partly like an engineered probe, and partly like something humanity does not yet possess the scientific language to classify correctly. The deeper investigators push into the data, the more another possibility emerges beneath the surface. The object may not have been designed to remain visible permanently. Think carefully about its behavior across the entire timeline. As it approached the sun, thermal activation exposed hidden compounds and increased its visibility dramatically, expanding dust plumes, releasing organic materials, and intensifying electromagnetic signatures. The object became highly observable during the exact period when human scientific infrastructure could study it most effectively. Then, after passing Jupiter, the process completely reversed as outgassing weakened, the dust envelope dissipated, thermal activity declined, and visibility dropped rapidly as the object accelerated back toward interstellar darkness. Within months, it will become nearly impossible to observe directly again. Observable during approach, invisible during departure, creating a temporary window that opened and closed with extraordinary precision. According to some analysts, if an advanced intelligence were designing a system intended to briefly announce its presence during an inner solar system transit before disappearing safely back into deep space, it would behave almost exactly this way. This possibility has forced a growing divide inside scientific communities, where one side continues defending the natural object explanation, while the other side believes the total pattern exceeds mere coincidence due to its obvious intentionality. Meanwhile, the opportunity for further investigation is rapidly disappearing as 3i Atlas moves beyond the strength of Earth-based telescopes, with recent Hubble imagery showing its brightness fading far faster than earlier models predicted. As 3i Atlas continues disappearing into the outer darkness beyond Jupiter, the focus of the investigation has shifted once again. Researchers are no longer asking only what the object was, but are now asking something potentially even more important. Why did humanity choose not to follow it? Despite possessing operational deep space technology, advanced launch systems, and global tracking infrastructure, no emergency intercept mission was authorized, no accelerated probe deployment entered development, and no coordinated international effort emerged to pursue what many scientists privately considered the most anomalous object ever recorded entering the solar system. According to independent analysts studying the institutional response, that decision reveals far more than the object itself. Human civilization has launched expensive space missions toward far less significant targets before, spending billions sending probes toward ordinary asteroids, distant comets, and icy moons based purely on scientific curiosity. Yet here was an object potentially older than the solar system carrying impossible isotopic signatures, executing precision gravitational maneuvers, releasing preserved organic compounds, and displaying behavior that challenged conventional orbital models, yet no pursuit mission moved forward. That contradiction sits at the center of the growing debate surrounding 3i Atlas. From a strategic perspective, the timing for interception was unusually favorable, as the object passed directly through the inner solar system, entered Jupiter's gravitational environment, and remained observable for months. Existing launch infrastructure could theoretically have supported rapid response mission concepts, especially through international cooperation, where even a limited flyby probe could have collected historic amounts of data before the object escaped permanently. But according to analysts examining internal communication patterns between major institutions, the idea never advanced beyond preliminary discussions due to practical caution and the extreme technological challenges involved. However, many independent researchers no longer believe logistics alone explain the silence. Instead, they argue something much more consequential occurred after the GUI spacecraft completed its observations, and the James Webb analysis confirmed the object's extraordinary age. Institutional science may have reached a quiet consensus behind closed doors, a consensus not about immediate danger, but about absolute impossibility. They realized that 3i Atlas represents a level of cosmic history and engineering far beyond our current ability to influence or fully understand, leaving us with no choice but to watch in silence as it returns to the interstellar void. What do you think? Did 3i Atlas execute a calculated, intelligent sweep of our solar system? Or is there a natural cosmic explanation for all of these anomalies that science simply hasn't unlocked yet? Share your thoughts in the comments below. Leave a like if you found this deep dive intriguing, and make sure to subscribe and turn on notifications so you never miss our next investigation into the ultimate mysteries of outer space.